Welcome to Architecting for Failure, why are distributed systems so hard. My name is Markus. I do work for Lightbend as a so-called developer advocate, you know, all that fancy living and traveling and staying in wonderful hotels and speaking to you guys and connecting with community. I actually do that for a living, and there's one thing I can tell you, it's not that fancy as you might think it is. It involves a lot of travel at the end of the day. I do have a little bit of spare time though, and in my spare time I do organize my own conference in Germany, so whenever you want to drop by, it's happening in a theme park, and it's called Java Land. It's pretty neat. I do speak at pretty much all major Java conferences around the world, and I am reachable on Twitter. This is where I'm pretty active at myFear. Why are we talking about distributed systems in general, and what are distributed systems at all, right? That's the big question these days. I want to take a little bit of a step back and tell you something around system evolution in the last couple of years, and speaking of couple, it's probably more than 20 or even earlier than that. So we all started out on the pretty much left side, at least I did. So systems like AS400, mainframe systems sitting in the basement, the big iron things. Who actually ever had the pleasure to work with AS400 systems or anything like that? Lucky you, so at least a little bit. Let me tell you one thing, in most big enterprises you will find out that they'll still run the core of their business. They've been designed for extreme uptime. They've been running since hundreds of years, literally, and at some companies you actually might not even find somebody who knows how to reboot those systems, which is pretty funny. They've been really, really expensive, and they still are up to today. So it's been custom, hand-tailored hardware by IBM, by other big players, and they've been designed to be completely highly available without any additional clustering or any additional distribution, right? So centralized systems. What was the bottom line? Mostly the expenses, right? They were just too expensive, those systems. So with the advent of commodity hardware, like the Linux boxes that we could just use to shovel in a 19-inch rack, those commodity hardwares made it way more interesting to build systems that are no longer super expensive, but more distributed, or let's say replicated. And those kind of shared state systems are commonly referred to as enterprise systems because they actually work on replication on a clustered model. They were designed for availability, but not on a hardware level, mostly on a software level. One particular system comes in mind, talking about Java EE or even earlier versions. Those came up because of those new approaches. And what are we seeing today that everybody wants to talk about? Cloud and microservices is pretty much the next evolution of that whole system design approach. Self-serviced infrastructures that are not only designed for availability, but designed to handle failure. They are completely virtualized, they are in the cloud, individual services, distributed. And this is what we refer to as cloud or software serverless approaches, for example. Where does that bring us? If we look a little bit into my personal experience and prediction over the last couple of years. So around the 80s, 60s, 90s, there's been a lot of mainframes. We still do a lot of enterprise projects as of today. So let me do a little survey here. Who's actually using Java Enterprise Edition or Spring or centralized Java instances? Okay, so I'm just curious, what else are you guys using, like Ruby on Rails or lightweight stuff? Okay. what are we moving into? And this is literally kind of groundbreaking for our industry these days, is the cloud. And if you look at my personal prediction, beginning today, those cloud instances will definitely be way more distributed and available in enterprise settings. So whenever you start a project with your customers or clients, they might actually want you to look into some kind of cloud offering. But why exactly did that happen? Like, is that only a cost thing? Like, did we only want it to change from big iron to commodity hardware and to pay-as-you-go models? Or is there something else in here? What are today's biggest problems in your project? What are the biggest problems you have? Just shout at me. I'm just curious. Want to make sure you're all alive after that coffee break. Again. Distribution of your newly built app, like deployment, right? Testing, that's interesting. Okay, reuse of components, that's what you said, or? Okay, build something that can be reused. Who else said something? Scalability, right. So Lightband did a little survey. We always do that for charity, you know, and we want to learn a little bit about the industry we're working in and we're catering to. And this is kind of a little bit of a cutout from one of our recent surveys, asking for the biggest problems you are facing in your software development project. So developer velocity was one, high infrastructure cost, comparable small 11%, awful downtimes in terms of it's just not working, it doesn't scale. Release frequency was another really big block in terms of deployments, and meeting demands, whatever that means. Let's dig into that a little bit more. Meeting demands. So this is a nice graphic I came across a couple of months ago, and it shows you the number of internet-connected devices. So if you compare like around 1997, where J2EE back in the day started, like the centralized replicated server approach, we had a very small number of connected devices, of browsers accessing centralized infrastructures. That grew significantly. Spring came on board, tried to make J2EE usable and actually easy. After that, something like Ruby on Rails popped up because the whole Java thing obviously was bloated back in the days and inflexible and enterprisey, like all the bad words that nobody really wants to hear. Anybody an idea where that Ruby on Rails pilot kind of came from? Who started that? That was Twitter. So Twitter was the first service who actually needed something else that is not the JVM, that is not J2EE or Spring. And they wanted to have instant deployments, a very lightweight footprint. Back in the days, they actually started still with MySQL as a relational database backend. But they switched over and left the JVM infrastructure. Around 2000, between 2007 and 2009, Akka was invented by Jonas Bonaire as a fully actor-based implementation on the JVM. And as you can see, already around 2011, the term microservices was actually coined. I haven't heard about microservices back in the days. That's like a more recent thing for me. The Reactive Manifesto was created 2013, and it defines a lot of requirements for truly distributed systems. My personal prediction here is that we'll see way more connected devices and new business cases actually around those availability of sensors. Who actually has like a real modern house with a couple of sensors to like do the blinds automatically or temperature stuff? That's a real great playground. Low cost, get a bunch of Raspberry Pis, program your own logic, a couple of teensy little motors and engines, and everything works pretty great. Developer velocity is another interesting aspect. It actually contains everything, starting from code and how it looks like, over methodology, how you actually develop your software, that's processes, the systems or deployment processes you're actually implementing, and also the people, which is something that we obviously as technology people can't really fix, right? So all those things are obviously still a big issue in our day-to-day projects. And especially the part where it comes to code, that you have too much technical debt, that you have too much complexity in your centralized infrastructures, that it's super hard to write tests for something that is existing because they need to be real integration tests, for example, and include the complete setup system, including test systems for integration partners and everything that you really need to run. Or there even are no tests at all. So I've seen systems that ran for more than 10 years and there was hardly any documentation available. Because back in the days, we just hacked stuff together and we were happy that it worked. And the guys developing those systems, they're out of business since a long time. Looking at release frequency, the block on top, what should we name it? Should we name it monolith? The most hated word in 2017. This is exactly what many companies still have. I'm not saying it's a bad thing. Simple CRUD applications, many other use cases that still will be sufficiently met by a monolithic infrastructure. But if that scales to the size of a WebSphere instance that takes 15 minutes to actually boot up before it's available, that's probably an issue. And if you have code changes in one teensy module that you have to introduce and you need to follow all the processes and methodologies, and it takes you half a year to put that thing into production, that's kind of outdated. If we get new regulations or governmental orders to change stuff, maybe in the insurance industry or in the finance industry, we need to implement them in a matter of months, especially in the context of the European Union. So those monolithic deployments don't really work anymore. So following that idea to cut down that monolith not only technically into modules and have a good software design, but recompose them into something in microservices and build that whole thing individually, you gain a lot more flexibility. Ultimately, you come to that point where you can deploy your microservice instance within minutes. Another little survey, if you're still up for it. Who's actually deploying twice a year to production? 4 times a year, so quarterly? Who's deploying monthly? Who's deploying daily? Okay, so we're still there. I think there are a lot of big examples out there where people deploy services on an hourly base, new and updated versions. And this is definitely something that can have a big business impact. The whole package out of all those individual findings and problems that our projects as of today have is exactly why we have microservices. And they promise to scale way better individually. They promise an easy deployment process, a quick deployment process, and they also promise an easy development process, right? Because they are so small and they are not a big complex application. They are independently testable. They are just the right size for something. I should warn you, because I personally consider microservices are not really a silver bullet in any way, for many reasons. And you know, I do have 2 daughters, 6 and 9 years old. They're both in school in Germany, elementary school. And the one thing they really hate is homework. So I usually have one slide in my presentations that has a bunch of bullet points on it. And I consider this your personal homework. So if you're really looking into building a distributed system, out of microservices, you definitely need to make sure that you meet all those requirements on this slide. And if you compare that to what you need to meet in terms of technical requirements by using a centralized application server, this is a lot of stuff. This is something that application servers usually give you, so you don't need to build your own microservice infrastructure. Gartner coined a term and they call this the outer architecture, for example. This is everything that puts you into the position to actually be able to build and deploy a microservice architecture. And you also need to keep in mind that while you're building a centralized system and you're putting complexity in your individual components, don't run into the issue with microservices to put this complexity in the pipes in between the components. This is something that we did a couple of years back, and it was called ESB, centralized services. We've connected web services, did all kinds of magic in the ESBs or integration infrastructures, and ended up with something fancy. Took us a couple of years to learn how to handle that and how to scale ESBs, but yeah, don't run into that problem. This talk actually talks about failures, right? So I really would like to shed a little bit more light on this particular aspect. So how do we handle failures differently? We know that those two architecture types have two different requirement sets. They have a different way of building those individual systems. But how do we handle failures? I've seen that a lot, and I hated it. I've actually been once grounded for a couple of days because some volcano on Iceland actually broke, and yeah, that was funny. I took a car and rode X hours back home. It wasn't fun. Application servers are kind of the one thing that takes care for everything that we could ever ask for as a developer. They make sure networking and threading is addressed. They introduce distributed transactions. They shared resources on our behalf, right? So they gave that manageability of clusters to ops. The picture you see is like an animal, a fairy tale animal in Germany, and it literally is the one thing that does it all, if it's not obvious at that point. And this is how I like to picture application servers. We've been literally spoiled. We only had to learn a couple of well-standardized APIs that were even interchangeable between the different vendors. And we could just write a servlet. And we knew it would perform and behave the same way in the different servers, right? Standardization led to the success of those centralized, replicated infrastructures. We handled failure more or less the same way. There's been a couple of discussions around checked versus unchecked exceptions, but mostly we've been catching something at the very top tier of our application, and depending on if we know what kind of failure it was, we decided to actually give the user a hint or give him a failure page. It wasn't easy, honestly, but we could manage. I personally built some pretty complex applications, maybe for German automotive OEMs and insurances, and they've been multi-million-dollar projects. And they've been all built in that monolithic way, right? But if something really failed, this was the outcome. Do you know which server this runs on? Huh? It's BEA WebLogic server, swallowed by Oracle. Those were the times. The idea was, if it ain't broke, don't fix it, right? So we've been happy. I've been happy. I've personally been happy many, many years. Why can't we just be happy for microservices, and why is that so different? This is a totally feasible deployment overview of a microservice-based system. I'm not 100% sure, but this could easily be Netflix as of today. So does it look like a well-crafted architecture diagram? Probably not, right? So kind of scary at that point. The big difference here, obviously, is how we distribute the individual parts of our application and how we scale them. And we scale them individually, right? We end up having a well or not well-oiled machinery of individual components that really need to work together in order to make that whole thing work. And that gives a lot more chance for failure or even inconsistencies in the complex system, which could definitely be a couple of services or even hundreds of services. Does that sound interesting, or is that something I want to look at? I'm starting to sweat already. Like, I want a help button with that microservice stuff, right? So that's not something that comes natural in no way. So I'm going to show you a couple of patterns and examples, and they're all built with something that is called Logon. It's an open source project, Apache licensed. You can all go to github.com/logon right now, download and build and do whatever you want with it. There is no commercial parts of it. It's completely free. It's built on top of Akka and Play and is a microservice framework for the JVM. And it actually builds in all the patterns I'm talking about today, which makes your life way easier. This is just a personal recommendation. So let's start with those patterns. You've heard about circuit breakers, right? What does it mean? So let's just think about services that are chained. All those fancy users accessing services, and during a normal operation, a circuit breaker sits in between two services and is in a closed state. If a service fails, the circuit breaker in most cases can be configured. So after a certain threshold of failures, the circuit breaker opens and sends an error directly back to the calling instance. That gives you a lot quicker response times than having to wait for any kind of HTTP status codes, network failure, ping times, or whatever. If after a certain minutes the call succeeds again, the circuit breaker closes and starts to let calls through again. How could that implementation look like? Sounds complex, and if you've seen the talk earlier, probably about reactive spring, there's been a framework mentioned that's called HiStrix. So yes, for sure, you can use HiStrix for that kind of circuit breaker implementations. In this example, I obviously used Logon. What you see here is an endpoint definition of a Logon service, and adding a circuit breaker is just a matter of calling a method and putting it on a particular service call on this individual service. And this is built in by default, so you don't really have to use an additional framework. It's just part of the service API, so you can use it as it is. But there are a couple of more patterns that you definitely need to think about, and there's not a technical solution for all of them, which is unfortunate, but also interesting. You can actually work around failures in general. So maybe not every call in your application is necessary for a certain functionality. Let's think about something that I call the eBay clone for a reason. So the user is actually searching for some items in the database, and we have a search service that uses a bit service that uses an item service to get all the item details. And both services, both bit and item service, return the information back to the search service. And if everything works fine, this thing is smooth as it could go, right? But what happens if something breaks? For example, the item service, who displays all the individual descriptions for the particular item you want to bid for. How do we want to handle that failure? At the search service level, we can decide if we want to return a complete failure in the veins of centralized applications and just let the user know there's nothing to see right now because something failed, or if we actually still want to return the bidding information for that particular item. Even if we can't see the nice picture and the description for the very moment as part of the web page, we might still be interested in the actual bidding that's going on. So that's a business decision, more or less. And here's a story, I don't even know if it's true or not. When Amazon Prime Video came to Germany, they did a big launch, all the advertising you can even think of, and they had a big hiccup in their payment gateway. So for the first couple of hours, that payment gateway was not working. Make a guess what Amazon decided to do with people who bought videos or rented videos. Did they get an error? Shout at me, let me know. Definitely not, because Amazon wanted this thing to be successful. And at that point, they made the business decision to not pay and to not let users pay for anything. They just gave away the videos and rented movies, just to make that definitely a success. That's more a business pattern, right? So we also need to learn how to define our applications in a different way. Not only build them and make them rock solid and secure and think about failures, but also start to define them differently. How do we catch errors in Logon? This is just Java 8, the completion stage API. You can simply use it, definitely catch an error, and that's all it takes from a programmatically level if you can convince the business decision makers to really go down that route. But there's also another approach that you could use. It doesn't have to be the coded and built in. You could also go with publish and subscribe mechanisms, right? Everybody's talking about Kafka these days. That might be an interesting aspect. Search for something, get something back, have queues and messages, publish and subscribe mechanisms in the back end. If you want to do that with Logon, this is how you actually publish the result from an item service call, in this case, to a topic, which is pretty much a one-liner on the very bottom. And if you want to subscribe to such a topic with Logon, this is a little bit more, but looks familiar, at least to some of those Java E folks that's been working with JMS messages and queues. So the general message is always have a plan B, thinking in microservices and distributed systems. You can start thinking about fallback patterns. Instead of directly accessing the actual information in the database, you could think about having a certain amount of data in a cache and only displaying that cached information, maybe with a little warning, might be outdated, refresh in a couple of minutes. You need to decide if you want to trade in resilience for accuracy or latency. That is something that is commonly referred to as the CAP theorem, and CAP stands for consistency, availability, and partition tolerance. So you can only choose two of the three. And this is something that you also need to keep in mind because it is another new thing in designing distributed applications. Who of you has seen that slide? The fallacies of distributed computing. Just reading down that list should make all of us giggle because none of those are true. And it's sad but true that we definitely need to work around and keep those in mind. So it's a little bit about thinking the worst instead of assuming that a centralized application server will take care of us. We are kind of the grown-up developers now. We need to start thinking about the implications of what we do, and we need to start embracing failure instead of working against it. If I want you to take something with you today, I think the biggest thing is distributed systems are hard because they fail often. And writing those systems is definitely not as easy as some vendors might tell you. And I'm not making a big thing out of this. A distributed system has a lot more complexity, a lot more things that you need to think of and about. So it will definitely cost you more than building just a monolithic application. Coordination between those individual services is probably the hardest part. So if you've been working with RESTful endpoints, if you've been sticking them all together, you've made your first experiences, maybe that's definitely not the only and maybe not the best way to connect your individual endpoints and services. And another thing that I find really funny is it's slow will be the hardest problem that you will ever have to debug, because you have no idea where that starts. If it's an individual service, because that is fast and quick on my machine, but when it gets published to the cloud and distributed, it might actually not be fast anymore. Where do you go from here? Like, how are we building applications tomorrow? If we're thinking about microservices as cloud-based applications, as resilient applications, robust applications are kind of the past. So robust is something that can be implemented with a certain buffer to handle change and failure. Resilient is distributed in microservices. Maybe the future after microservices is something that is anti-fragile, something that doesn't break that easy. Maybe we will get a microservice distributed systems runtime that has a certain amount of AI built into it and can identify bottlenecks on our behalves. So there's a lot of interesting thoughts how that distributed systems space can develop further, especially in the microservices end. But we're not there yet. We're all still making our experiences around microservice-based architectures. If you have a little bit more time today, tonight, tomorrow, you should definitely give Logon a test drive. You know that Lightband is also known for being the company behind Scala, the programming language. Have no fear. Logon actually has a full Java API. We're not hiding anything. You can completely use Java-based APIs. The official project website is the logonframework.com. There's a tremendous amount of documentation available. And there are a bunch of examples that you can dig through, which might be interesting for you. If you want to learn more about the basic concepts behind Logon as a framework, our CTO, Jonas Bonner, wrote this little free report. So just go there and download, register, and you're all set. And it's a pretty good read. But boy, do you know how definitely disappointed I was when I realized he was writing a book and I just started as a developer advocate and I didn't write a book? That was really hard. So I definitely wrote a book. And if he's talking about architecture, I need to talk about development. So you could definitely download my book too. And it's also free, just register. It's a nice PDF. It walks you through an example application, which will be easy for you to follow. Thank you for today. If you have any questions, I'm more than happy to take them. Otherwise, there might still be some coffee left out there.